Imagine you are the chief financial officer of a global manufacturing giant. You're sitting at your desk, hovering your finger over the mouse, and you're about to wire $20 million for a single massive piece of automated machinery.
Oh, wow. Yeah, that is a terrifying moment.
Right. Because if that machine works the way the engineers promised, you essentially own the market for the next decade. But if it fails, or, worse, if it hurts someone on the floor, your company could be facing bankruptcy.
It genuinely is a make or break moment for any executive. I mean, when you reach that level of capital expenditure, you are stepping entirely out of the realm of basic corporate procurement.
Yeah, buying a $20 million stamping press isn't exactly like expensing a new laptop for the marketing team.
Exactly. Or building a new facility, right. You're entering this high-stakes life cycle that blends really intense, unforgiving financial mathematics with the gritty physical reality of factory floor maintenance.
And today, we are exploring exactly that life cycle. Welcome to another deep dive. Our mission today is to unpack a critical business superpower, which is how companies evaluate, purchase, and ultimately maintain massive capital equipment and facilities.
Because it's not a simple journey.
No, not at all. We want to understand how an idea on a boardroom whiteboard actually survives the gauntlet of corporate finance to become a humming, profit-generating piece of machinery.
Right, and to really get the context for this, you have to picture a bustling, state-of-the-art manufacturing plant. It's loud, it's incredibly fast, and every single square foot of that space represents a massive financial commitment.
A huge one. Yeah.
So to get from a basic business plan to that humming factory floor, a company has to navigate a very specific minefield. They have to master capital budgeting, ruthlessly evaluate their opportunity costs, and finally, figure out how to keep both the humans and the machines safe over the span of, decades.
So let's start before that $20 million check is even signed. Because before a company can even look at a glossy catalog of shiny new factory equipment, they have to figure out how to evaluate the money they're about to spend.
Right.
And maybe more importantly, they have to account for the money they've already lost. So where does this whole evaluation process actually begin?
Well, it begins far away from the factory floor, usually in an executive boardroom, with something called sales and operations planning, or S&OP.
Okay, S&OP.
Yeah, you can think of S&OP as kind of the great translator of the business world. It takes a company's long-term, high-in-the-sky strategic vision and translates it into a tangible operating budget. And critically, for our discussion today, it establishes a capital budget.
The capital budget being that designated pool of money set aside specifically for massive long-term investments. We aren't talking about printer paper and break room coffee here.
Right, no.
We were talking about new product lines, major equipment, entire plant modernizations.
Exactly. But allocating that capital requires a level of ruthlessly objective thinking that is, frankly, often very difficult for human beings to maintain.
Oh, I'm sure.
Yeah. Decision makers have to wrestle with two crucial financial concepts before they spend a single dime. And the first one is opportunity cost.
Okay, so I hear opportunity costs thrown around constantly, usually in very casual contexts, like the opportunity cost of going to a party instead of studying. But in the high-stakes world of capital budgeting, what does it actually represent?
So opportunity cost is the return on capital that could have been achieved if the money was invested in the next best alternative. Because, you can't spend the same dollar twice. Yeah. If you decide to spend $10 million building a new distribution warehouse, your opportunity cost is whatever profit you would have made if you had invested that $10 million into, say, a new enterprise software system instead.
Okay.
Or even just the guaranteed interest you would have earned leaving it in a high-yield account. You are constantly weighing your chosen path against the ghosts of the paths you were saying no to.
Which makes sense. I mean, you have to prove that building the warehouse is definitively better than buying the software. But you mentioned a second concept, one that I know trips up almost every major corporation at some point.
Yes, the sunk cost.
The dreaded sunk cost.
It really is. A sunk cost is money that has already been paid and cannot, under any circumstances, be recovered. The absolute golden rule of capital budgeting, and perhaps the hardest one to follow, is that sunk costs are completely irrelevant to future decisions.
And this is where human psychology really goes to war with good business practice. I always think of it like going to a terrible 3-hour movie.
Oh, that's a perfect analogy.
Yeah, like you buy a ticket for $20, you sit down, and after 30 minutes, you realize it's the worst movie you've ever seen.
Yeah.
But you stay for the next 2.5 hours, suffering, just because you already spent the 20 bucks.
Exactly. It's incredibly difficult to ignore sunk costs because walking out feels like you are giving up.
It feels like admitting defeat. You don't want to waste the money.
Right, but the money is already wasted. You're just wasting your time on top of it. Now, let's step away from the movie theater and look at a massive corporate scale.
Okay.
Suppose a tech company spends $50 million building a custom factory for a revolutionary new smartphone. But by the time the factory is actually built, the market has shifted entirely to a competitor's ecosystem.
Oh, yikes.
Yeah. Consumers clearly do not want this phone. It's dead on arrival.
Okay, so the instinct in the boardroom is going to be immense pressure to launch the phone anyway, right?
Right.
Executives will say, we already spent $50 million on the factory. We have to build the phones to try and recoup some of that investment.
Yeah, that is exactly what happens. But that $50 million is gone. The concrete is poured. If running the factory and marketing the doomed phones is going to cost another $20 million and only generate $10 million in revenue, they are just digging the hole deeper.
They're throwing good money after bad. The fact that you lost $50 million in the past does not justify actively choosing to lose another $10 million in the future.
Exactly. You have to walk away even if it means abandoning a brand new state-of-the-art facility. But executives push forward all the time out of pride or fear of how the board will react to a write-off.
Which is why you can't just let the ghosts of past bad investments force you into these terrible decisions.
Exactly. And this is exactly why companies cannot rely on gut feelings or emotional momentum. They require rigorous, objective capital budgeting tools to strip the human emotion out of the spending.
Okay, so we establish our capital budget through S&OP. We commit to ignoring our sunk costs, and we weigh our opportunity costs. How do we actually do the math to prove an investment is worth moving forward? I know there's this massive evaluation gauntlet to get through.
Oh, the gauntlet is relentless. Potential investments are put through a step-by-step methodology to prove their financial viability. First, they face the more basic hurdles, which are return on investment, or ROI, and the payback period analysis.
Wait, I have a basic question here. If we are looking at the payback period, why isn't that simple calculation enough?
What do you mean?
We'll say I'm proposing we buy a machine for $10, and the engineers tell me that machine is going to generate $2 of pure profit every year. The math is incredibly straightforward. 10 divided by 2 is 5. It takes 5 years to pay it back. After year 5, it's pure profit. Why do we need to complicate it with heavier financial modeling?
Because that simple back-of-the-napkin math ignores a fundamental, unavoidable law of finance, which is the time value of money.
The time value of money.
Yeah. $1 resting in your hand today is objectively worth more than $1 promised to you 5 years from now.
Because inflation eats away at the purchasing power.
Inflation is a significant factor, yes. But it's also about risk, and tying right back to our previous point, opportunity cost.
Oh, right. Because you could have invested it.
Exactly. If you have the dollar in your hand today, you can invest it in the market and earn interest immediately. If you have to wait 5 years to get that dollar, you lose 5 years of potential growth. There is a cost to waiting. So, if a project passes the basic payback period test, it is forced to move on to the heavy hitters that mathematically account for this time value of money. The most critical one being net present value, or NPV.
NPV, okay.
There is also the internal rate of return, or IRR, and finally, eligible projects are ranked using a profitability index.
We really need to do a serious deep dive into net present value here, because this seems to be the linchpin of the entire capital budgeting operation. If the time value of money degrades our future profits, how does NPV actually account for that degradation?
It accounts for it by basically running the process in reverse. We take all the money the machine is expected to generate in the distant future, and we mathematically shrink it down to what it would be worth if we magically had it in our hands today.
Okay, so we're discounting it.
Exactly. We apply a discount rate to those future cash flows.
So it functions like a financial time machine. We are teleporting future dollars back to the present day so we can see if they're actually worth more than the upfront price tag we have to pay right now.
That is a great way to put it, yes. That is exactly what is happening. And the further out in the future the money is earned, the more heavily it gets penalized or discounted when we whiz it back to today.
Now, I want to avoid reading complex algebraic formulas over audio, because literally nobody wants to do mental math with exponents while they're driving or washing dishes.
Yeah, definitely not.
But let's walk through the exact conceptual example from the sources to ground this in reality.
Let's do it. Let's set up the scenario. Imagine you are pitching an initial investment of $20,000 for a new piece of automated equipment.
Okay, 20 grand out of pocket today.
Right. Now, the engineers estimate this machine has a 20-year operational life. The financial team runs the projections and estimates that it will generate $5,000 in annual cash inflows every single year for those 2 decades.
Okay, so $5,000 a year for 20 years. 5 times 20.
Yeah.
The total cash generated is 100 grand.
Yep.
Sitting in a meeting, that sounds like a no-brainer. You spend 20,000 today, you get 100,000 back over time.
If we lived in a vacuum where time didn't exist, yes, it's a brilliant investment. But the company has determined that their cost of capital, meaning their required minimum return on any investment to justify the risk, is 12%.
12%. Okay.
That 12% is our discount rate. So we have to turn on the financial time machine you mentioned. We take that $5,000 per year, and we reduce those future periods back to their present value using that 12% penalty.
Right, because 5 grand 10 years from now is worth way less than 5 grand today.
Exactly. And this specific setup, by the way, with equal payments every year, is called an annuity calculation.
Okay, so when we run that time machine, what happens to our $100,000?
Well, when we shrink 20 years of future $5,000 payments back to today's value at a 12% discount, it doesn't equal $100,000.
Obviously not.
The money in year 19 and 20 is penalized so heavily by the time it gets back to today that it's worth just a fraction of its future amount. So the present value of all those future inflows is actually only $37,350.
Wow, that is a staggering difference. The simple passage of time and the requirement to beat a 12% hurdle just vaporized over $60,000 of perceived value.
It did. The time value of money is a brutal reality check. But we aren't quite done. $37,350 is just the present value of the money coming in.
Oh, right. We have to account for the upfront cost.
Exactly. To find the net present value, we have to subtract the money going out. So we subtract our initial $20,000 investment from that present value.
Which leaves us with a net present value of $17,350.
Precisely.
So because that final NPV number is positive, it's greater than 0, it means the investment successfully beats our 12% required return, even after accounting for the brutal degradation of time. It survives the gauntlet.
Yes. From a purely mathematical standpoint, it is eligible for funding. And if a company has multiple projects that all have positive NPVs, they might look at the internal rate of return, which finds the exact interest rate where NTV equals 0, just to see which project has the highest buffer.
Sort of like a safety margin.
Exactly. Or they use a profitability index, which divides the present value of future cash flows by the initial investment, to rank the projects by efficiency and see which one gives the most bang for the buck.
You know, I am looking at this entire NPV calculation we just did, and I have to say it feels like a giant house of cards.
Wait, really? How so?
Well, think about it. The entire calculation, the only reason that net present value was a positive $17,000 is completely dependent on a massive assumption. We assume that the machine survives for its 20-year estimated life. If a critical gear shatters in year 5 and the machine has to be scrapped, all of this brilliant financial math goes up in smoke. We don't get 20 years of inflows, we get 5. We lose our shirts.
That is entirely true.
So how does a company financially insure against mechanical reality?
That is the million-dollar question, and it perfectly bridges the boardroom and the factory floor. Because a capital investment is only a spreadsheet fantasy until you can prove you can physically maintain it in the real world.
Right.
And this is where we introduce a crucial operational philosophy called total productive maintenance, or TPM.
Now, when I think of industrial maintenance, my mind immediately goes to, like, a guy with a toolbox sprinting across a factory floor because a conveyor belt just snapped and production has completely halted.
Yeah, that is reactive maintenance. And in a high-stakes, highly capitalized facility, reactive maintenance is an absolute disaster. Total productive maintenance, on the other hand, is entirely proactive.
Proactive, meaning before it breaks.
Right. It is a philosophy built on the idea that scheduled downtime and preventive maintenance are just as critical as active production time. It's not about fixing things when they break. It's about servicing them with such precision that they never break unexpectedly.
Okay, let's move away from basic examples. Let's think of TPM like aviation maintenance. Commercial airlines, they do not wait for a jet engine to start smoking mid-flight before they decide to look at it.
No, that would be horrifying.
Right. They pull the plane out of service after a strictly defined number of flight hours, and they completely rebuild the engine, even if it is currently running perfectly.
That is the exact mentality of TPM. It requires intense, unwavering discipline.
But I could see a massive point of friction here. In a manufacturing setting, scheduled downtime means the line is stopped. 0 units are being produced. Every hour that machine is being proactively inspected is an hour. It isn't generating that $5,000 annual cash flow we promised the CFO.
I know, it sounds bad on paper.
Doesn't shutting down a perfectly working line destroy your profit margin?
It seems counterintuitive, I'll give you that.
Right.
But TPM actually preserves the profit margin over the long haul. The benefits are profound and systemic. First, because you aren't constantly dealing with catastrophic, surprise breakdowns, your production schedules become highly predictable.
Okay.
This ensures flexibility and continuous flows.
Which means you don't have to stockpile massive, expensive mountains of inventory just to act as a buffer for when the machines inevitably explode.
Exactly. It requires less material handling, less wasted floor space, and honestly, just less chaos. But most importantly, tying it directly back to our finance discussion, TPM is the insurance policy on your net present value.
It guarantees the 20-year lifespan.
Exactly. It guarantees that the 20-year lifespan you promised the spreadsheet actually happens in the physical world. It builds resilience into the entire system.
It keeps the math honest. You have to sacrifice a small percentage of daily uptime to guarantee the multi-decade lifespan.
And there is another critical non-negotiable benefit to TPM that naturally shifts our focus here. A well-maintained, predictable machine is fundamentally a safer machine.
Which brings us to the ultimate foundational requirement of managing capital facilities: health, safety, and environment compliance, or HSE.
Yeah. You cannot extract long-term value from a $20 million facility if it is fundamentally unsafe for the people operating it or if it is actively poisoning the environment around it. The HSE requirements are comprehensive and they are not optional.
And we aren't just talking about generic safety posters in the break room, right? What is the actual strategic application of HSE on a modern factory floor?
Well, it covers regulatory compliance across the board. It mandates the efficient use of energy, water, and minimizing industrial waste. But the core operational focus is always protecting employee health.
Right.
This includes the mandatory use of personal protective equipment or PPE hard hats, specialized respirators, whatever the specific hazard dictates. But it goes far beyond just handing out safety glasses. It is about engineering safety directly into the physical processes.
Yes. For example, the protocol known as lockout-tagout. When I first learned about this in the source material, it completely changed how I viewed industrial safety.
Lockout-tagout is a literal lifesaver. Think back to our scheduled TPM downtime. When a massive automated press is being serviced, you have a human worker physically inside the machine.
Which is terrifying.
Very. And you cannot rely on someone simply shouting, "Hey, don't press the start button." Human reliability is too fragile. Lockout-tagout means the primary power source of the machine is physically padlocked shut. And a tag is placed on the lock identifying the specific worker who holds the only key.
So the machine physically cannot be re-energized until that specific worker finishes the job, steps clear of the danger zone, and removes their own personal padlock.
Exactly.
It takes safety out of the realm of human error and shifts it into the realm of physical impossibility.
It is brilliant engineering applied to human behavior. Another prime example of this is how chemical and material hazards are communicated. In a massive facility, you have hundreds of different substances. You manage this through the Safety Data Sheet, or SDS.
Now, a tired factory worker at hour 11 of a grueling shift shouldn't have to read 3 paragraphs of dense small print text to figure out if a chemical is going to burn them.
No, which is exactly why the SDS is highly standardized and heavily reliant on universal visual icons. It bypasses cognitive fatigue entirely. It uses instantly recognizable pictograms to communicate danger regardless of language barriers or exhaustion levels.
So you see a stark black triangle with a flame icon inside. You don't need a degree in chemical engineering to immediately know highly flammable, keep away from sparks.
Exactly.
It bypasses the reading brain and hits the instinctual brain.
That is the goal of HSE. Immediate, unmistakable hazard communication coupled with physical protocols that prevent harm.
Yeah, I want to push back on a perception here.
Yeah.
Because we spent this entire deep dive talking about financial optimization. And I know that some companies, or maybe some executive, perhaps the same ones running those brutal MPV discount rates, might cynically view all this HSE compliance as nothing more than an expensive hurdle.
Oh, absolutely.
They see it as red tape, right? Just another line item driving up costs, forcing scheduled downtime, and delaying production.
It is a grievance you hear constantly in certain circles, the idea that safety slows us down.
But based on everything we've unpacked today, I'd argue that mentality is incredibly short-sighted, even from a purely financial perspective. Controlling noise, waste, stopping pollution, and preventing worker harm, it isn't just about following rules to avoid a government fine. It is fundamentally about preserving operational productivity.
100%.
If your factory floor is so hazardous, loud, and toxic that your employee turnover rate is 50%, your production's going to tank because you're constantly training novices.
The hidden costs of an unsafe culture are massive.
Furthermore, ignoring safety protocols is exactly how you invite catastrophic failures. One major industrial accident doesn't just cause tragic human suffering, which is obviously the primary concern. But from the boardroom's perspective, it instantly wipes out that beautiful net present value calculation we spent so much time on.
Yep, it's gone in an instant.
The machine is destroyed, the factory shut down pending investigation, and the investment goes to zero overnight.
If we connect all the dots, your analysis is spot on. Safety and environmental stewardship are not opposed to financial success. They are the bedrock foundation that allows long-term financial success to even exist.
Right.
You simply cannot maintain a high-performing capital asset that is inherently unsafe. The operational risk profile becomes catastrophic.
Well, we have covered an incredible amount of ground today. Let's trace the full journey of this capital investment for you to wrap this all up. It is a really fascinating, complex life cycle.
It requires a tremendous amount of discipline at every single stage.
It starts entirely in the abstract, requiring you to ruthlessly evaluate opportunity costs and brutally ignore the sunk costs of past failures.
Right.
Then, it demands that you mathematically travel through time, using net present value calculations and discount rates to prove that future cash flows are actually worth the upfront price tag today.
And if the idea actually survives that financial gauntlet and gets funded,
the reality of the factory floor immediately takes over. It requires rigorous, disciplined, total productive maintenance to keep the machines running and to ensure that the 20-year lifespan you promised the spreadsheet actually happens in reality.
Exactly.
And finally, that entire sprawling structure, the finance, the maintenance, the production, relies entirely on a non-negotiable foundation of health, safety, and environmental compliance.
Which leaves us with a rather important final thought to consider.
Oh, let's hear it. What should we be pondering after exploring this entire life cycle?
Think about this. If a company flawlessly executes all of that complex financial math, if they perfectly calculate their internal rate of return, master their S&OP, and successfully wire $20 million to purchase a state-of-the-art facility,
Okay.
but they completely ignore the physical culture of maintenance and worker safety on the floor, did they actually make a smart business investment? Or did they just use very elegant math to purchase a very expensive, very dangerous ticking liability?
Wow, that really reframes the entire process. Because at the end of the day, you aren't just swiping a corporate credit card for a piece of metal. You're building an ecosystem that relies just as heavily on human culture and discipline as it does on financial modeling.
Could have said it better.
Well, thank you for joining us on this deep dive. Keep questioning the world of business around you, look past the spreadsheets, and we'll catch you on the next one.